let's try question 14. Water flows at a constant rate into a large tank. The tank is a cuboid with all sides of negligible thickness. The base of the tank measures 8 meters by 3 meters, and the height of the tank is 5 meters. So it's all shown here. And then there's a tap at the point T at the bottom of the tank, as shown in figure 5. At time t minutes after the tap has been opened, the depth of water in the tank is h meters. And then, so just be careful in here, it says the depth of the water in the tank is h meters. Yeah, so h means the depth of the water. And the water is flowing into the tank at a constant rate of 0.48 meter cube per minute. Yeah. So clearly meter cube has to be the volume, the units for the volume, and it's per minute. So then we can write this as dV over dt. So the rate of change of the volume by time, that's equal to flowing into the tank. So it should be positive 0.48. And the water is modeled as leaving the tank through the tap at a constant of 0.1 h meter cube per minute. So they are the same units, meter cube per minute. So we can just use them straight away without changing anything. And then because it's leaving the tank, so it has to be negative. So that would be minus 0.1 h. And then part A show that according to the model, 1200 dH over dt equal to 24 minus 4h. Okay, so we need to set up the equation. So for this type of equation, we always need to use the chain rule because clearly there's no information given for the rate of change of the height by time. We only have rate of change of volume by time, so it's dV over dt. So to set this up, we know dH over dt has to be equal to dH over something times by something over dt. And we already have dV over dt here. So dV over dt is the one to link them. So we have dV over dt. So it has to be, the second one has to be dV over dt. And then to link them, the first one at the bottom has to be dV as well. So we already know dV over dt, which is 0.48 minus 0.1 h. So now we just have to find what's dH over dV. So meaning we need to find an equation, volume in terms of h. And then because h is the depth of the water, so that means V has to be the volume of the water. And then to work out the volume of the water is quite simple in here because we already have the base is 3 meter and 8 meter. The height is just h, and it's in the cuboid. So if the water is in the cuboid, the volume of the water is same as how we work out the volume of the cuboid. So then V has to be equal to 3 times by 8, so base times by height, so h. So then the volume is equal to 24h. So therefore dV over dH is just equal to 24 here. So that means dH over dV is just the reciprocal of dV over dH, which is 1 over 24. And then times by dV over dt, which is 0.48 minus 0.1 h. So that's what dH over dt equal to. And what the question wants is 1200 dH over dt. So we just times by 1200 then. So 1200 dH over dt is just equal to 1200 times by 1 over 24, 0.48 minus 0.1 h. So simplify that, we have 1200 dH over dt equal to, so times them up first, 1200 times by 1 over 24, that's equal to 50. So 50 times by 0.48 minus 0.1 h. So then 1200 dH over dt is equal to 50 times by 0.48 is obviously 24. And then 50 times by 0.1 h is just minus 5h, which is what they want in part A. So 4 marks, that's all. And then part B, they want us to show that according to the model, H equal to A plus B e to the power negative KT, where A, B, K are constant to be found. And then they gave us the condition. So given that when the tap was opened, the depth of the water in the tank was 2 meters. So basically it just means when T equal to 0, at the very beginning, when T equal to 0, depth of the water is H is equal to 2. So T equal to 0, H equal to 2. That is the condition we're going to use later. So now we just have to integrate it. So what I will do is, because clearly we can't integrate it straight away because this is H and then this is dt. So we can't integrate H with respect to T. So we need to use what we learned in the differential equation, separation of variable. We move all the H to one side and all the T to the other side. And then we can't plus or minus, and we only can times something or divide by something for both sides. So in this case, there are two terms. So we have to just divide the whole thing for both sides. So 1200 over 24 minus 5h. And then dh over dt, we times dt for both sides. And then once we divide the whole thing over, we only have one left because anything divided by itself become 1. Then we took the integral for both sides. So now we just have to integrate it one by one. So 1200 is the coefficient, so just keep as 1200. And then integrate 1 over 24 minus 5h. So since it's a linear expression, so it just be ln of 24 minus 5h. And then because it's a linear expression, we just divide by the coefficient of h, which is over negative 5. And then 1 will integrate to t plus c. So 1200 divided by negative 5, that will simplify to negative 240, and then 24 minus 5h equal to t plus c. So then ln of 24 minus 5h equal to negative 1 over 240t plus c divided by anything is still some constant. Let me just use d to represent it. Yeah. So then 24 minus 5h equal to e the power of negative 1 over 240t plus d. So 24 minus 5h equal to e the power of negative 1 over 240t times by e the power of d, because it's a sum on top. So when you use the indices rule, it will be e the power of negative 1 over 240t times by e the power of d. And then, like always, we change e to the power d into some other constant. Let's use capital A to represent it. Now I think it's easier if we use the condition. So when t equal to 0, h equal to 2, substitute in. So that would be 24 minus h equal to 2, 5h will be 10. That's equal to a times by e to the power of anything times 0 is 0. So e to the power of 0 is 1. So a is just equal to 14. So therefore, the equation will now become 24 minus 5h equal to 14 e to the power negative 1 over 240t. So then plus 5h for both sides, and then minus 14 e to the power negative 1 over 240t for both sides. So h is just equal to 24 over 5 minus 14 over 5 e to the power negative 1 over 240t. So that would be the final answer for part B. So in this case, A, that would be 24 over 5, and then B would be negative 14 over 5, and then this little k here would be 1 over 240. And then for part C, given that the tap remains open, and then we want to determine according to the model whether the tank will ever become full, giving a reason for your answer. So this one, they just ask you, if T keep increasing, what's H gonna be? What's the maximum possible value of H can be? So for this one, we can just use the equation we just get. So if we let T go to infinity, that means either part negative 1 over 240t will become 0, because that's how we sketch the exponential diagram. So it's negative power, so it has to go something like this. So if t keep increasing, eventually it will become 0. So therefore, h is equal to 24 over 5, and anything times 0 becomes 0, so just 24 over 5 left. And then 24 over 5 is roughly 4.8, which is smaller than 5. The maximum height is equal to 5. So therefore, the tank will never become full, because the maximum height the water can reach is only 4.8. It's always smaller than 5. That's how it works.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.